Next is how we can make a salt or methods of preparing a salt. So basically, what is salt? When hydrogen of a acid is replaced by the metal, we call that as salt. Like example, HCl is an acid, but in place of hydrogen, if we write any metal, then if it is NaCl, then what it will happen? It will become a salt. Same thing, H2SO4, which is a sulfuric acid, but if it is replaced by any metal, say calcium, so then it will become salt. So hydrogen of acid is replaced by a metal, we call that as salt. How we can prepare the salt? So there are different ways. The reaction of acids are basically the methods of preparing a salt. First one is acid-base reaction. When acid react with base or acid react with alkali, we'll get a salt. Second one is acid plus metal. What we'll get salt and hydrogen. Third one, acid plus metal carbonate will give salt, water, and carbon dioxide. And acid plus this base can be metal oxide or metal hydroxide. So base neutralizes the acid. The common bases are metal oxide or metal hydroxide. Both can be refers to base. But if hydroxide, which can dissolve in water as well, we call that as alkali. So all alkalis are bases, but all bases are not alkali. For example, calcium hydroxide is partially soluble. So calcium hydroxide is a base, but we don't say it is an alkali. Why we don't say it's an alkali? Because it is partially soluble. So this is a base, part of a base which can dissolve. We call that as alkali. So soluble bases are known as alkalis, and the reactions of acid are used to prepare these salts. Because you have to learn how to prepare salt and how to extract salt. That's from O levels. And you should also revise the table in which you study how to which salts are soluble and which salts are insoluble. So the salts which are soluble and insoluble, some of the salts are aqueous, can dissolve in water, and some of the salts are insoluble or remain solid. All nitrates are soluble. Salts which have NO3 at the last, they all dissolve. Most chlorides are also soluble. Most sulfates are also soluble. And most of the carbonates are insoluble. But exception is there that 3 of the chlorides are insoluble: mercury, silver, and lead. 3 of the sulfates are also insoluble: barium, calcium, and lead. 3 of the carbonates are soluble: sodium, potassium, and ammonium. So these exceptions, most chlorides are soluble except mercury, silver, and lead. Most sulfates are also soluble except barium, calcium, and lead. Most carbonates are insoluble except potassium, sodium, and ammonia. So these are the carbonates which are which are soluble. Other carbonates are insoluble. This is a table which you have to learn or memorize. And the methods of preparing these salts. So method of preparing a soluble salt, experimental technique. Example, if we use an insoluble base such as metal oxide or metal hydroxide, but insoluble, does not dissolve, or metal or solid carbonate. So first what we will do, we will add a solid base to acid, gently heat. Why? Because to speed up a reaction, so reaction can occur. Normally it is heating is done for metal oxide. Metal oxide does not react at room temperature easily. Reaction is very slow. That's why we we supply heat energy. So we take a container, and this container is filled with acid, and using a spatula we add a base or a metal oxide. We add until no more dissolve. So until no more dissolve, we can remove by filtration. And then after removing it by filtration, what we are left with? We are left with salt solution. So as we are left with salt solution, then there are two methods to obtain a salt from the solution, either evaporate or do crystallization. But now practically crystallization is done in the lab. Evaporation is not done. For a small scale it can be done, but for a large scale you need too much heat energy to evaporate all of the liquid. That's why we heat and concentrate the solution, then we cool down, then we filter, and then we dry. Is it clear how to obtain a salt from insoluble base such as metal or metal carbonate? Any doubt in this? These points are important. The percentage yield of the crystal will be less. Like example, if theory suggests I should get 2 grams of crystal, this is a theory suggestion that I should get 2 grams of crystal, but practically I will not get 2 grams. Why? Because when I heat, concentrate, and then filter the solution, so some of the filtrate left on the filter paper, so there is also losses on a transferring from one container to another. That's why I will always get a lower yield. Any doubt in this? Any doubt? And the second method to obtain a soluble reaction between acid base. So you have to recall the idea of indicators. So what you will do, you will fill by using a pipette or a measuring cylinder. You will transfer acid into a conical flask. Measuring cylinder advantage is that it's fast, but in disadvantage, inaccurate. Advantage of pipette, it's accurate, but disadvantage, it takes time to transfer the solution. So using a burette, using a pipette or a measuring cylinder, we will transfer the acid or alkali. Normally acid, because they're more corrosive, having greater corrosion rate. So we use acid in a small scale and transfer them into a conical flask. Acid and alkali both are colorless. So what we will do, the second thing, we will add a drops of indicator. Not too much, only drops of indicator. Different indicators have different color in acidic and alkaline medium. You have to learn the color of indicator. For example, phenolphthalein is colorless in acidic medium, but in alkaline it will turn pink. So if I use a phenolphthalein here, it will be colorless. So it will be colorless originally, because if you add an indicator phenolphthalein, then what you will do, you will use a burette and you will fill this burette with an alkali. There's a bottom, the tap is there, and you will fill the scale. Top is 0. The smallest value which a burette can read is 0.1 centimeter cube. So when you open the tap, acid is added, the alkali is added to acid, or acid is added to an alkali. Once all of the acid used up, the solution become alkaline. So as the solution become alkaline, you will have an identification at what range you will have, at what volume of acid reacted with an alkali. Then you will repeat the experiment without indicator and use either crystallization or evaporation. So an indicator can be used to show when the acid and alkali have completely reacted to produce a salt solution using a titration method. Then repeat the action without indicator. Why we are repeating without indicator? Because if indicator is there and we extract the salt from a solution which contain an indicator, so it will be a colored salt, or crystals will also have a color of the solution. So using a same volume, then follow the method for reducing the volume of solution and evaporate, and you get the crystals out. Is it clear? How to extract, how to obtain a salt by reaction between acid and base. Any doubt in this? Because you should learn these experiments to prepare a soluble salt. So we can use reaction of acid with insoluble base, metal or metal carbonate, or we can use a soluble base, use a titration technique in which we mix two solutions together. Is it clear? Any doubt? Any doubt in this? Okay, so this is the last topic of today's class. So we started with the concept of the moles, the ratio of the moles, finding moles, finding volume by ratio, then the reactions of acid. We'll continue this topic one tomorrow, in which we discuss how to prepare insoluble salts from the solution. So I'll end the session and share the recording.